Hi everyone, today we shall talk about sampling. That's the process by which we select a subset of a population in order to carry out a survey, the results of which we hope to generalize to the original population in which we are interested. These approaches are applied when we need to ensure that we have enough data on specific subpopulations in which we have a particular interest. In this lecture, we shall first discuss the historical approaches to sampling and how weaknesses in them produced some famous mistakes that led to the development of modern methods such as random sampling. We shall also talk about multi-stage cluster sampling, which extends basic random sampling to address issues that arise when it may be logistically or financially difficult to use simple approaches to sampling. We shall also talk about oversampling and stratification. Let us first introduce some terms that must be on your fingertips. Surveys attempt to learn about a population from a sample. Essentially, a survey attempts to generalize the lessons learned from a sample to the entire population that the sample represents. Sampling itself refers to the process of choosing a representative sample. That is, how to pick sampling units so that they represent the population's characteristics in the right proportions. Now, there are two broad types of surveys. If we can access every member of the population, then the survey is called a census. Otherwise, we have a sample. This sample must truly represent the underlying population for whatever characteristic we want to observe. In fact, the field of surveying and sampling studies how to draw such a representative sample effectively and efficiently. If the sample is not representative, the conclusions that we draw about the population will be erroneous. A sampling unit or an individual is a unit of observation. In other words, it is an element on which an observation can be made. For example, a person or a household. A population is a collection of all the sampling units regardless of whether we can access it or not. For example, all the people living in the UK represent its population. However, in practice, even the official records may not represent the exact population. For example, the official records may not have contact details of every person living in the UK, and therefore an interviewer may only be able to draw a sample from these official lists. Hence, a sampling frame is a set from which an interviewer or a surveyor can draw the sample from. A population is thus an abstract concept, whereas a sampling frame is its practical realization. So, how do we choose between census and sampling? The first factor is speed. For large populations, sampling will be much faster than census. Therefore, we can get the information faster and take actions accordingly. For example, if you want to know the political climate prior to the polling day, you will have to use sampling. Cost is another important factor, and accessing a large population in a census costs much more than sampling. Therefore, a census requires large budget, and usually only governments conduct a census. Accuracy is extremely important if we want to learn the correct information from our survey. Obviously, the census should provide the most complete information. However, due to advancements in sampling methods, a properly conducted sampling may reasonably approximate the census. Also note that while accessing a large population, such as in a census, quality control becomes a major challenge. After all, you may have to rely on a large army of surveyors and account for a large percentage of errors in data recording. this can decrease the accuracy of your information. In contrast, exercising quality control is easier while collecting a smaller data sample. So although sampling is great, if it is not carefully conducted, it produces a non-representative or a biased sample. To understand that, consider this question. Suppose I want to know whether my class needs a break right now. Now, whom should I ask? Is it enough to ask the opinion of those seated right in the front? Is it okay to simply ask the men or only the women in the class? Clearly, you can see that any of those approaches will exclude other segments within the class and hence produce a biased or non-representative opinion. Now consider another situation where you want to gain people's opinion on some product or issue. So you contact people from the telephone listings only. Does that produce a representative sample? Now, not everyone may be listed. So to avoid that, a technique called random digit dialing can be used, where digits are randomly selected to make a phone number. Hence, we can reach the non-listed people as well. So are we good? Well, not really, because significant samples of population may not have phones. Moreover, there can be a non-response bias. That is, people are not always willing to talk to surveyors. To avoid that, surveyors either call multiple times or offer incentives such as cash for filling in the survey. For example, here is a letter sent out by the Office for National Statistics in the UK that offers a £25 cash incentive for filling in a survey. So in the two examples, you can see that if sampling is not through carefully and mitigating strategies are not employed, we risk having biased samples. And biased samples can produce erroneous predictions. Non-representative sampling is also called non-probability sampling. And an example of non-probability sampling is quota sampling. In quota sampling, a population is divided as per some characteristics. And the proportion of population falling in each division is noted. For example, here a hypothetical population in a white-dominated country is divided according to race and gender. Since the sample size is set to 1,000, quotas in the sample are allocated to each division according to the percentages in the population. The surveyors then fill their quotas of observation as it suits them. And that's where the problem lies. For example, the surveyors may go to one place where white males typically hang out and complete all their observations from there. Or they may only contact people on the street who look helpful. Clearly, the sampling units are thus not chosen randomly, and hence the sample is a non-representative or a non-probability sample. George Gallup used quota sampling to successfully predict the winners of 3 US presidential elections from 1936 to 1944. The quotas in the samples were allocated to characteristics such as age, gender, race, and some other observable traits. However, in 1948, the prediction turned out to be wrong, and this iconic image from Wikipedia shows the actual winner, Harry Truman, triumphantly smiling while holding a copy of a newspaper that predicted his defeat. The image has become an icon of bad polling. The sample collected for this opinion poll was biased because it relied heavily on the discretion of interviewers in selecting the respondents. Also, the proportions used to allocate quotas were based on data from 1940. In 1948, this data was well out of date, especially because the World War II and high urbanization in the US had changed the demographics significantly. Another form of non-probability sampling is purposive sampling. In purposive sampling, the researcher has a particular purpose or group in mind. For example, the top business executives. An expert then decides who is eligible to be a part of the sample. For example, some subjective criteria are used to define what is a top business executive. Do you decide based on salary, the size of the company, or some other criteria? Hence, purposive sampling works if the expert judgment is sound. However, typically it is a challenge to convince others that this judgment is indeed sound and that it produces a representative sample. Another problem with purposive sampling is if it concerns a hard-to-track population. For example, top business executives or drug users are not easy to access. So snowball sampling is used where you pick up the samples as you go. Essentially, you request each respondent to connect you with the next sampling unit. Again, this does not necessarily produce a representative sample. Another common type of non-probability sample is called a convenience sample. It is so called because the researcher uses whatever sampling units are easily available, rather than selecting from the entire population. Because some members of the population have no chance of being sampled, the extent to which a convenience sample, regardless of its size, represents the entire population cannot be known. Notice non-probability samples can help in exploratory research though. Therefore, a scientist can demonstrate that a particular trait occurs in a population by documenting a single instance. For example, the assertion that life does not exist outside Earth can be falsified by finding just one planet that hosts life. Likewise, if a researcher is simply documenting the different coping strategies that patients of AIDS use, then a non-representative sample is still useful. However, what we cannot do is to conclude whether any of these coping strategies is more common than the others, because to decide that, we need a representative sample. Because of these limitations, representative or probabilistic sampling has become popular. So let's examine that now. The first example of probabilistic sampling is called simple random sampling. To ensure that there is no bias in the sample, it is vital that the probability of every sampling unit is the same. Hence, simply selecting from the street outside does not represent random sampling because not everybody is equally likely to be there. Also, contacting all the respondents must be easy. Otherwise, the sample will overrepresent easily contactable sampling units. Such a probability sample will estimate a parameter of the original population. Now here a parameter is some property of the population that we want to estimate. A common parameter of any population is the mean value for certain characteristic. So for example, we may want to estimate the mean water consumption in a population. In such conditions, the sample calculated will be random, and any difference between the sample and population characteristics is simply due to chance and not due to some systematic bias. The procedure to create a random sample involves getting a sampling frame and then randomly selecting from it. For example, if we want to survey our university students, then the sampling frame is the list of contacts of all the enrolled students. Therefore, we use a software such as R to randomly select students from this list. Another example of probability sampling is called stratified sampling. Much like in quota sampling, a population is divided as per some characteristics, also called strata. And the proportion of the population falling in each stratum is noted. For example, Here, a hypothetical population in a white-dominated country is stratified according to race and gender. Since the sample size is set to 1000, portions in the sample are made for each stratum, according to the percentages in the population. Unlike the quota sampling, where the interviewers select sampling units based on their discretion, here sampling units are chosen randomly from within each stratum. So that's the crucial difference. This ensures that the sample is a representative sample. An advantage of using stratified sampling over simple random sampling is that small percentages of the underlying population are guaranteed representation in the sample. For example, here non-white females are only 2%, and due to chance, they may be missed altogether in a random sample. However, a fixed allocation of 20 in the sample ensures that non-white females get their representation. Stratified sampling sometimes oversamples small percentages. So for example, the allocation of non-white females can be increased in the sample to allow them a greater say in opinion polls. Random sampling, be it simple or stratified, can be expensive. Consider this example. Suppose you want to select a sample of 100 from 6 cities of varying populations. Suppose you use simple random sampling using some software like R. Here is a result of random sampling. The R code to generate this sample is given in the description under the video. It turns out that although cities with larger population have greater representation, as expected, all the cities are represented in the sample. Now, if the survey requires in-person visits to every sampling unit, then the interviewers must travel to every city. This can break the surveying budget. To reduce the surveying budget, especially when in-person visits are required, clustered sampling is used. Clustered sampling sees clusters of populations and samples from them in a hierarchical fashion. Let's see an example. Suppose our sample size equals 100 as before, but now instead of randomly sampling the individual households from all the cities, we sample the top level clusters, that is the cities. Suppose we sample only 4 cities randomly. Notice the probability of selection of each city is proportional to its population. Otherwise, smaller cities are as likely to be selected as the larger ones, and that is problematic because they will be overrepresented in the final sample. As we sample subclusters within the cities, we can sample them also according to their sizes. So for example, within the selected cities, we sample 5 localities from each city. Again, the probability of selection of a locality depends on its size. So we continue to the next subcluster, that is blocks within each locality, and we sample 5 blocks. Then finally, we sample 1 household from each selected block. Thus, we sample 100 households as intended. This is confirmed by the multiplication on your screens. Because in cluster sampling, some entire clusters are excluded, resampling can produce significant variation in the results. Thus, for subsequent statistical analyses of cluster samples, we must make adjustments. However, the details of those adjustments are for a more advanced class. Note, while drawing conclusions about a population from a sample, a large sample size is important. However, whether that sample size represents a large percentage of the underlying population is relatively unimportant. This is why, even for large populations, to the tune of several hundreds of millions, Often the sample size is only a few thousand. The advantages of probability samples are that they are representative of the underlying population on all characteristics. The interviewer's convenience or discretion is no longer an issue. Various statistical tests that we shall study later assume a probability sample. Therefore, having a probability sample allows applying statistical analyses. However, probability sampling has its challenges as well. The first challenge is that we must have a sampling frame that is a true reflection of the population. For example, we can have a list of all the students registered in a university, but having a complete list of all the citizens of a country is hard. Likewise, just because we randomly select sampling units doesn't mean they will all respond equally well. Avoiding non-response is a key challenge to ensure that the sample remains bias-free. Random selection may cause inconvenience in accessing and require significant budget to access. For example, if you must physically visit the sampling unit, then random sampling may require you to travel far and wide in the country. Also, in stratified sampling, the detailed information of different strata may not be known. For example, if ethnic information is not recorded, it is not possible to stratify the sampling frame according to that information. We shall finish this lecture off by posing a question to you. The survey question here is, do current students in your city love chocolates? Now you have a bunch of options in front of you. You must label them as to whether they are probability samples or not. If they are probability samples, are they simple random samples or stratified samples? Leave your answers in the comments beneath, and we shall see you in the next lecture. Goodbye.